So today we are going to study entity relationship type model. So yeah, I think I'm able to. So this model actually is serving as the first step of design an application database. So this model basically will produce a diagram to show the basic data and relationship that's supposed to be captured in the database design. Okay. So this slide shows the outline. Maybe I need to turn into the, yeah, shows the outline of this chapter. So we basically will study the key elements of the ER model, and we're going to study ER diagrams notation, and then we will going to use a company database as a sample database to show you how to design an ER diagram for an application database. So this slide actually shows the main phases of the database design. So basically, the database design always start with the mini word. So mini word basically is representing a real world organization or application that we need to design a database for. And given the mini word such as bank database, university database, like the social media database, and so on, we first need to obtain the requirements collection and analysis. So the requirement collection and analysis may be kind of written by the users who want a database to be designed and implemented. And this can be also written by or edited by the database designer. So they need to go to the clients to collect requirements of the database and analyze how the database will be designed. Okay, once we have the requirements collection and analysis, then we can go to the next step. That's actually called conceptual design. So the conceptual design will end with ER diagrams. So the ER model basically used for the conceptual design. So at the conceptual design level, we don't worry about any implementation details. We don't worry about how data will be stored, how data will be changed and updated. We only focus on what type of data will be stored in the database and their relationship. Once we have the ER design, then we can move on to the next step. That will be the logical design. So logical design basically means that we can convert ER diagrams into relation schemas or table schemas. So that's called logical design. So from conceptual design to the logical design, usually we call there is a conceptual schema mapping. So we map ER diagrams into relation schemas, okay? Then the next step, or the last step, will be the physical design. So physical design, we will consider which system we want to build our database on. So we may have different server type we can choose, or we can have the centralized database or virtual cloud-based database. And for the physical design, also we mainly consider how data will be stored, like the physical formats, storage format for every attribute. And also we may consider if we need to create some index on certain attributes to speed up the database search. And also we may want to create some views so that those views can better serve the user's query. So those are the kind of within the scope of the physical design. So this actually the design path on the right. So design path on the left, those mainly refer to the database application developer. So for the application developer, they need to analyze what kind of operations that any user may use. So then they're going to for the application analyst, they're going to collect those end users requirements regarding what kind of options, what kind of functions they usually want when they work with a database. And then this application analyst will pretty much design the functions, we call the kind of transactional functions definition, and then we'll send those definitions to the application developer. So those developers will basically develop the programs either using high-level programming language like the Java, Python, and so on, or use the database own high-level programming language like PLSQL to serve to implement those functions, so that the end users, they just call those functions to perform whatever operations that they need to apply on the database system. Okay, so this is roughly the database design phases. And for ER design, we pretty much only focus on the conceptual database design. Okay, so before we discuss the key elements of the ER design, we first look at a company database description. So basically, you have to have this description in order to design a database. So the database description is the first thing you have to have before you can design that database using the ER model. So here, in this company, for simplicity of discussion, we actually oversimplified a lot of data requirements. So we only have 4 data requirements that are showing here in the bullets. So the first one, the company is organized into departments. So each department has a name, number, and an employee who manages the department. We keep track of the start date of the department manager. A department may have several locations. So if just simply from this paragraph, we can tell that the company really wants to store a department information. Okay, so department information, not only all department information, because it does specify what are the information that we need to collect for the department, like the department name, number, and the manager information. Okay. For the second paragraph, each department controls a number of projects. So each project has a name, number, and is located at a single location. So this paragraph also tells us that we also need to record the project information, okay, store the project information. So besides these 2 paragraphs, besides detailing what kind of information need to be stored for the department and project, these 2 paragraphs also describe certain relationship between those kind of real-world entity. For example, a department may have several locations, okay? And also, the second one, each department controls a number of projects, okay? So it does show that there's a relationship between the department and the project, and this relationship pretty much very clear. Department controls project. So what does that mean? It means that besides we record the information for each project, we also want to record which department is the controlling department of that project. So that's what the entity relationship means for. So we need to store the entity information such as department and project. We also need to store the relationship among those entities. For example, department controls project. So that's what the entity relationship means for in the ER modeling. The next page, it shows that we store each employee's social security number, address, salary, sex, and the birth date. Each employee works for one department, but may work on several projects. We keep track of the number of hours per week that an employee currently works on each project. We also keep track of the direct supervisor of each employee. So this paragraph simply shows that we need to store the employee information also. And there's some kind of relationship. For example, each employee works for one department. So there's employee relationship between the employee and department. And also may work on several projects. That's already indicate there's also a relationship between the employee and the project. Okay. Then next one, each employee may have a number of dependents. For each dependent, we keep track of their name, sex, birth date, and relationship to employee. So this paragraph basically shows that we also need to record the dependent information, okay? So overall, we just have a quick review of the data description. I think we may then think of that in this database design, we have at least 4 types of the real-world entities. One is department, then the project, then the employee, and then dependent, okay? So those are the entity types. So by entity types, we mean that a type of entity that have the same real-world semantics and also the attributes, number of attributes. So we're going to go back to review this data description later. So let's move on to the next one. So then the purpose of the entity relationship model is simply we want to sketch a database design. So in this design, we only capture the types of data that we need to store in a database and how those data are related. Okay, so but in the ER design, we do not want to record how data changes. So we only record the type of data and their relationship. So that's the main purpose of the ER design. So then the outcome of the design is basically we're going to have a ER entity relationship type, entity relationship diagrams, okay? And then once we move on, after we finish the conceptual design by producing an ER diagram, the next step we were going to convert the ER diagram into relation schemas. So then, based on those relation schemas, we can create tables on whatever database systems you pick. And this slide shows a simple ER model. So we can tell that in these small ER diagrams, we have 2 entities or 2 types of entities, customer and a book. So they all represented using the rectangle box. So each entity will also need to describe what are the attributes we want to describe that entity. For example, for the customer, we're going to record address, name, and class ID. So address further can be split into several components like straight number, should be straight name number, and state and zip. And for the book, we basically just store 3 attributes: name, ISBN, and copy number. Okay. Then it does also show there is a relationship between the customer and the book. So this relationship is called reserves. Okay. And for each relationship, we also record the constraint for the relationship. Okay. So how do we know the reserves? Which entity types that reserves used to describe? So basically, there is kind of a line connecting an entity type like customer with a relationship type. So since this reserve connecting to book and also connecting to customer, that means that these reserves describe a relationship between customer and book. Okay. And then this relationship type constraints so can be represented in at least 2 ways. So in this way, it shows the minimum, the maximum, this kind of a pair. Okay. So the minimum shows that given a customer, how many relationship instances a customer can participate. Okay. Or in other words, so 0 means that a customer does not reserve any book, so there's no relationship instance. Then capital N indicates multiple, so that means that a customer may reserve multiple books. Okay, so this gives a very kind of flexible constraint, means that a customer may not reserve any book, or a customer can reserve multiple books. Okay. On the book side, there is also a constraint 01. Okay. So 0 means that a book is not reserved by any customer. Okay. 1 means that a book can be reserved by only one customer, I think, at a given point of time. So that's very reasonable. Okay. So then you can tell that for the ER diagram, we have the rectangle box representing anti-tabs. We have this diamond box represent the relationship tabs. We also have the constraints to describe each relationship tab. And for the anti-tab, we also have the attributes to describe each anti-tab. So that's pretty much what a standard ER diagram looks like. Questions? Then we just review some key concepts like entities and attributes. So entities are the things and objects in the real world that will need to be represented in the database. So an entity, for example, in the company database, we may have entities for the employees, entities of the project or department entities, and dependent entities. And if we think about the university database, we may have student entities, we may have classroom entities, we may have the class entities, also we may have the college entities. Okay, so for the online banking, we may have the entities for the customers, accounts entities. We may have also representative or staff or clerk entities, and also we may have some loan entities and so on. So entities simply representing a real world object or things. The attributes are used to describe entities. Okay, so for example, for the employee, we may want to record the employee's name, SSN, address, sex, and birth date. So regarding what attributes need to be used to describe an entity, that is solely based on the application and application requirements. Okay, and also for a specific entity, it should have a value for each attribute. Okay, for example, an employee entity may have the name, like John Smith, SSN as 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't think this is a valid SSN, but anyway, as an example, address like 731 Fountain, Houston, Texas, and sex as M, and birthday as like January 9th, 1955. Okay. Now let's discuss types of attributes. The reason we need to identify the types of attributes because in the ER notation, we do use different notations for different types of attributes. So for the simple attributes, that means that for a given entity, that entity had a single atomic value for that attribute. For example, if we have an employee entity type, and the employee has attributes like SSN, DIN number, salary, date of birth, and age. So those attribute values are considered as atomic value. So those are considered as simple attribute. So simple attribute means that, for example, using SSN for each employee, then that employee can have only one SSN. Okay. Then for the same employee, that employee should have only one salary. So it means that salary attribute can only take one value, and that value is not decomposable, means that we cannot further split that salary value into several subcomponents. And similar for the age. For the DOB, you may think, oh, we can divide the DOB into the month, day, and a year. I think usually, in order to representing an accurate date, we usually have to use all of them. So, so DOB might not be the best example for the single, but atomic or simple attribute. But still, we consider DOB as a simple attribute in the sense that each person can have only one DOB. Okay, so each entity should have a single value on the DOB, and usually in order to represent a birth date, we have to use all of them, all the components together. Then for the composite means that an attribute is composed of several components. And here so some examples, like when we record address. So if we use address as an attribute, for example, for an employee or customer, then that address actually can be further split into several components, and each component has really a very clear semantic. For example, we can record address as either apartment number or house number, then the street name, city, state, zip code, and the country. So that's kind of usually the standard way to represent a complete address. Okay. Another one is that, for example, we also record a student's name or employee's name. So we can use a single attribute name to represent a person's name. But usually a person's name can have at least two components, usually three at the standard: first name, middle name, and last name. So in this case means that if we use address as a single attribute to represent address of a person or of a business, then that single attribute address is called composite attribute because it has several components. Similar for the name, if name is an attribute, then name is considered as composite because it contains multiple components. Usually in the database design, we use parentheses to indicate the composite attribute. Then, this shows that sometimes composite attribute can form a hierarchy because even the component of an attribute can be further split into several fields. So here shows address. Okay, so address is considered as component. It has street address, city, state, and zip, and the street address can be further split into the street number and the street name or the apartment number. Then the other way we can classify the attribute type is called single-valued or multi-valued. By single-valued, we mean that for each given entity or real-world things or objects, that attribute can only take a single value. So like when we're asking, when we record a person's attributes or person's information, like age, SSN will be a single valued attribute because for any person, that person at any single point of time, that person can only have one age, and also theoretically, each person can have only one SSN. Okay, multi-valued attribute means that that attribute can take multiple values for a given entity, and we usually use the curly braces to indicate multi-valued attribute. And the example of the multi-valued attribute, for example, if you want to build a customer database, you want to collect a customer's phone number. Okay, if you only use one phone number field, then that field may contain multiple values. Why? Because customer may have their cell phone number, their land phone, home phone number, may have the business phone number, or some people may have multiple phone numbers. So in this case, if you only have a single phone number attribute, then that attribute may potentially have multiple values. Another one is that the color of a car. So it means that if you only use a single attribute color to record the color of a car, then that color can be multiple valued because a car usually have the interior color and exterior color. So that's really depending on the design. Okay. So then the complex. So complex basically means that an attribute is composed of composite and multi-valued attributes that nested arbitrarily to any number of the levels. So it's pretty much means that an attribute can be a multi-valued composite attribute. Okay. So let's see the example. I think this may give you a very good example. So for example, when we want to record the employee's education background. So an employee may have multiple degrees, maybe multiple bachelor degrees or one bachelor degree, multiple graduate degrees, okay? And for example, if a person got his PhD degree, then if you want to record that person's previous education, then that person may have a bachelor degree, master degree, and a doctoral degree. So for each degree, you want to record from which college that degree is obtained, and in which year, and in what kind of degree and the field. So in this case, if you really use a single attribute called previous degree to record all possible degrees that a person obtained, then this previous degree is considered as complex because for each degree, we have to record multiple fields. So each degree, previous degree, is composite attribute. And also, since a person may have multiple previous degrees, so that's why finally previous degree will be considered as a multi-valued composite attribute. So I want you to understand that we use parentheses to indicate subcomponent of an attribute. So in this way, previous degrees is composed for fields. Then we use these curly braces to enclose previous degree, indicate the previous degrees can have multiple values. So this basically means that previous degrees is a complex attribute. Any questions? It shows very complex attribute. So we have this curly braces. So I use color coding really to show kind of open and closing symbol. So this address phone is considered as complex attribute because address phone is enclosed by the curly braces, means that address phone is multi-valued. And followed by address phone, we have this parenthesis, okay, to indicate that address phone is also composite attribute. So then the address phone contains what? Contains two components, the phone and address. And the phone itself is also complex. So phone is a multi-valued composite attribute because phone is enclosed by these curly braces that indicate phone is multi-valued. And the phone is also followed by the parentheses to indicate the phone actually has two components, subcomponents, area code, and number. So phone itself is a complex. It's a multi-valued composite attribute. The second component of the address phone is address. So address here, if we see this parenthesis color coding, we can tell that address is a composite attribute. It contains street address, city, state, and a zip. And the street address component is also composite because it contains three fields. Okay, so if we draw this hierarchy, then we can end up with this kind of a more like a tree-like hierarchy to represent the address phone attribute. Okay, so address phone in this case is a complex, is a multi-valued composite attribute, and each component of the address phone can be further contains multiple components and so on. So now let's discuss entity types and entity sets. So in the ER modeling, we only need to model entity types. So entity types, like we see in the previous example, entity type is is modeled as a rectangular box, and this box has kind of branch out and connecting to several ovals. So those ovals indicate they're the attributes. Okay. So that's basically how the entity types will be represented in the ER model. So in the ER model, we only need to record entity types. Then the entity sets basically is considered a set of entities of the same entity type. In the ER model, we don't need to record or model the entity sets. We only need to model the anti-type. So it's kind of have very abstract, high level. So it's only records the anti-type name along with its attributes. Okay. And usually we need to underline the primary key of each anti-type. Then I think we have discussed the concept of the key in many lectures. So a key, the definition of the key is the same for the ER diagrams or ER modeling and relational data model. So a key is a set of attributes whose combined values are distinct for each individual entity. Okay, so entity, if it, in the implementation phase, entity usually will be represented as a record in a table. So each record should have a unique key value. Okay, and in the ER model, we usually underline the primary key. Okay, so means that if an entity type has multiple keys, we only need to pick one as a primary key and then underline that primary key. Okay, so primary key can be a single attribute or can be a composite Composite means that given a relation like anti-type like car, the primary key contains two attributes. Okay, so you need to understand the semantics. If we underline license plate number and state, that means the two together can make a key, but none of them can be a key. So license plate number cannot be a key, state cannot be a key, but if we combine the two together, then they can be a key. Okay, so keys must satisfy the uniqueness constraint and the minimality constraint. So uniqueness constraint means that in the context of the ER model, every entity in an anti-type must have a unique key value. Minimality constraint basically means that if a key has multiple attributes, then all attributes are needed to ensure or to satisfy the uniqueness constraint. In other words, the set of attributes must be minimal. You cannot have a redundant attributes in the set, in the key, okay? The primary key, I think we discussed so many times. So primary key means that if an anti-type has multiple keys, then we can pick one of them as a primary key. If an anti-type has a single key, then that key will be the primary key too. So if usually we have different names, so we have name for the primary key, and then we have the name for all the keys in the anti-type. So all the keys are called candidate keys. So then we pick one as a primary key. Then the remaining candidate keys will be called secondary keys. Okay. And the weak anti-type in the ER modeling, the weak anti-type basically means that an anti-type does not have a key. So weak anti-type, excuse me, weak anti-type usually happens when we finish our first design, ER diagram design for an application database. Then we perform some kind of optimization. We kind of try to remove the redundant information in the ER diagrams. Then we end up by removing, at the most of the time, we have to remove some redundant attributes in certain anti-types. Then we suddenly realize that some anti-type no longer have a key, means that even we use all attributes of that anti-type, then there still not be uniquely identify each entity in that anti-type. So we're going to discuss that later. So, but you need to know that there is possibility that we do have a weak anti-type after the design. Then domain of attributes, that's very similar to what we discussed in the relational data model. So domain of attributes basically specify the set of values that an attribute can take. Those are the valid values. And also domain should also cover the information such as the data type of the attributes and the storage format of the attributes. So now I think according to the so according to the data description, okay, data description is on the right, and then we can write down the attributes for each entity type that we can identify in the data description. So I think in the discussion, we do identify 4 entity types: department, project, employee, and dependent. So we just list the attributes for each entity type. So I think for the company, it said that we do have a department. We need to record department's name, number, and employee who manages the department. We keep track of the start date of the department manager, so we need to start it. And department may have several locations, so that's why we do need to record locations. But since location is multi-valued attribute, we need to use curly braces to enclose location to tell us that location is multi-valued attribute. Then for the project, I think we need to record project name, number, location, and also each project we also need to record the controlling department. Okay. And then for the employee, we need to record employees' social security number, address, sex, birthday, and each employee works for one department, so we also need to get their department info. And we keep track. We work on several projects. We also have to keep on the project info. But here, we keep track of number of hours per week that an employee currently works on each project. So in this case, there's one way we can represent is that we use a work-sum attribute, and this work-sum attribute will compose of project and hours, and then this composite attribute work-sum. But since an employee may work on multiple projects, that's why we use curly braces to indicate work-sum might be a multi-valued composite attribute. So it's complex attribute, okay? And for the name, we store social security address. I think, do we have a name here? But anyway, so maybe I think we missed something. Each employee, let me. Okay, each employee's name, social security number, and so on. So for the name, I mean, that's totally depending on your preferences. So I think in this example, I think the designers want to record name as a composite attribute, means that we use name as attribute's name, and then the name attribute contains 3 components. So in this case, name is considered as composite, then a dependent, okay? So that's kind of more like an initial information we can extract from the database descriptions. So those are the entity types notation information. Then we can draw these entity types into into the relation schema, not into the entity type. I'm sorry. So then the entity types here shows that the ER notations for the multi-valued attribute and for the composite attribute, okay? So if an attribute is enclosed in a single ovals, that indicate that attribute is a simple attribute, okay? If an attribute is enclosed in double ovals, that indicates that attribute is a multi-valued. So location of the department is multi-valued, okay? If an attribute is further branching out and connecting to several ovals, that indicates that attribute is a composite attribute. So basically, how do you identify the attribute or distinguish attribute from its component? So attribute always directly connecting to its entity type, okay? Since name directly connecting to the employee entity type, that means name is an attribute. and component, subcomponent of an attribute, they only connects to the attribute. They will not connecting directly to the entity type. Okay, so in this case, we can tell that name is a composite attribute. It further contains 3 fields. And then the work sum, it is enclosed in double ovals. That means it's multi-valued. And the work sum also has 2 subfields, project and hours. So in this case, it indicates work sum is a complex attribute. So those just are notations for the simple composite multi-valued or complex attribute. Okay. So I think we have discussed how to display. So this is finally what we have here after recording the entity type and its attributes. Sorry, my connection, I think there's some kind of connection problem. So this shows how we represent those 4 entity types in the ER model. So identifying the entity types is the first step for the ER design. Okay. So I think you shouldn't have any problem for those notation. And for the entity type design, we have to underline the primary key for each entity type. Okay. So once we identify all entity types, the next one we're going to identify the relationship among the entity types. Okay, so there are 2 ways we can identify the relationship type. One is directly infer from the data description, like I discussed in the previous slides. So for example, I think like each department controls a number of projects that indicate there's a relationship between the department and the project. And what else? Each employee works for one department. So that indicates an employee also related to a department. And another one, like an employee may work on several projects. That also indicate there's a relationship between the employee and the project. Okay. And also, there's another relationship. We also keep track of the direct supervisor of each employee. So this also indicates that we also need to model the relationship among the employees. Okay, so supervisor and supervisees relationship. Okay, so in this case, both supervisor and the supervisees are employees. So that indicates we may have a very special relationship type, and that relationship type relates entities like employee entities from the same entity type. And then each employee may have a number of dependents. That's really also indicate there is a relationship between the employee and the dependent. Okay, I'm sorry. So this is the first way for us to infer the relationship from the data description. But I want to remind you that if you infer the relationship, you should have the strong evidence. So you have to infer from the data description. You cannot infer from your real-world experience or your own thoughts. You think, oh, they need to have this kind of relationship or that kind of relationship. That's not the way for the design. You should fully follow the data description. Okay, no more and no less. Okay, that's the very important rule, because we do have some real-world lessons learned. I think maybe 10 years ago when I working with our undergraduate capstone project team, and one of the team was basically assigned to a company, and their main job was to design a database. Okay, so in their design, they start with the ER design. Because ER design, the nice thing about the ER design is that it is a diagram, so it's very easy to understand what are the data need to be stored in database, what are the relationship among the data. So I think my students probably think, okay, they may miss some information in the data description about some very important relationship. So they add those relationships in their design. And then it ended up that our client was pretty upset because they said that we wrote those data description. We are very clear about what we want to do in the database design. So for any things that we didn't write into the data description, that means that we don't need them. We should not be included in the ER diagrams. So I think that's really shocked my students, but they really learn a good lesson that when you design a database for your client, then you have to fully follow what they need. Okay, even you may think they miss some important information or miss some important relationship, then you have to go to them to ask them if they want to, like, to check with them if they also want to record this kind of relationship or not. But you should not put into your design without ask their permission, because that's really upset them, I think. But also I think for the good database description, they may have reasons for including the information and for excluding the information. So that's why we will not basically automatically add the things that you think should be included. Okay, so this is one way for the relationship among the anti-types. The second way is not that direct one, but it's the second way. Basically, we try to examine the attributes of each anti-type, and then to see if there's any attribute in the anti-type actually have the same semantics as some existing anti-type. So we're looking for the an attribute and an anti-type, and both representing the same thing or same semantics in the real world. Okay, so let me show you one example. Like in the, for example, in the employee anti-type, okay, we do have an attribute called department. I'm sorry, I think it's showing my network connection is slowed down again. So let me wait for 1 minute. Okay, so let's look at the attribute in the employee anti-type. So we have one attribute called department. We have one anti-type called department. So this attribute and anti-type, they both representing the same thing. Okay, same real world concept or entity. So that really indicate from this relationship, it indicates that there should be a relationship between the employee and the department. So let me probably simply draw okay. So sorry, I think it's no longer allow me to draw. Okay, so let me hate it. I think I don't know. Let me first. Okay, so let's forget about it. So basically, because of the department attribute and the department anti-type, then it's indicate that there's a relationship between the employee where the department attribute belongs to and department anti-type. So this relationship, I think, is pretty easy to understand. So that indicate employee works for a department. Okay, so that should be a relationship. So let me can I use color coding? So I have For example, department. I don't know how to represent it, maybe not color coding. So, okay. Then this department corresponding to a department entity tab. Okay. So using the same strategy, we can also find others like maybe I think we have a couple, but let's first discuss like the department. So in the department, we have a manager. Okay, manager is an employee. So the manager and employee, they are referring to the same thing, the employee. Okay, so manager and employee, I mean, they have the same, how do I say, semantics. They both belong to the employee. Okay, so that's indicate the manager is also indicate the manager of the department also indicate there is another relationship between the employee and department. So the first relationship called works for. The second relationship actually means that an employee manages a department. Okay. So can I do a copy? So manager is another attribute that we can refine into a relationship. Okay. Then what else? So for example, for the dependent, we do record the employee of each dependent. So this employee attribute also indicate so hard. Okay, I think I just gave up. So that means, can I, one more time, one more try. So that means employee can be also refined into a relationship between the employee and the dependent, okay? And for the project, we also have the controlling department. So that's another, that's also indicate that we can refine this controlling department into a relationship between the project and department, because controlling department and department, they are referring to the department, reward department. And then go back to the employee. So we also have complex attribute works on. So this attribute has a single, has two components, project and hours. So the project component also corresponding to the project entity tab. I think the two referring to the same thing. That's why we can refine this works on into a relationship between the project and employees. So unfortunately, I just cannot draw. I think in the past I'm able to draw it, but not right now. I cannot do it. It's so sad. So let me try. I think, do I have another? But anyway, so then the last thing, like a supervisor. Supervisor by itself is an employee, okay? So that means that we can refine the supervisor attribute into a relationship between an employee as supervisor and an employee as supervisee. So since this relationship basically connecting to two entities of the same entity type. This is called a recursive relationship. So let's probably see the final design. Yeah. Where's my final design? Just so let me move here to find. Okay, so this is actually the final design. Okay, so we refine department into a relationship works for. It's described which department an employee works for. We refine, we model this manager as a relationship between the department and employee, but the name for the relationship as the managers. Okay, so it shows that between two entity types, we can have multiple relationship types. Okay, but each relationship type must have a unique name. Okay, so we have works for, managers. So the relationship type name also really tells us the semantics for that relationship. And then from department, and then for the between the department and the project, we have a controls relationship describing which department controls a project. Okay, then because of this project in the worksum complex attribute, we also can model this worksum relationship into a complex attributes into a worksum relationship type. So between the employee and the worksum. And because of that employee, I think that's called employee, we attribute of the dependent. I think that's not a typo because when we record employee, we probably record the employee's name. So, or SSN, whichever you want. But I think in considering the privacy issues and data protection law, usually we don't want to record SSN value in your database. Even you want to record, you probably don't want to record them in your database directly. You may want to have like a backend. You may have the reference table to record the SSN of each employee, but that table should be highly, the access to that table should be highly restricted, or you may even consider using the encryption to store the SSN values. So that's kind of, I think, a lot of data privacy law and the data protection laws require you to do that. But it's strongly recommended that you never use SSN as the unique identifier for a person as employee, student, or faculty, and so on, or even customer. So that's why that employee in the dependent entity type will be refined into a relationship between the employee and the dependent. So what else? Okay, so I think finally we kind of have this kind of first draft of the ER design. And for the last one, the supervise. Okay, so supervise is a relationship. It's starting from the employee and the backing to the employee. So that's why this supervise is considered or called recursive relationship type. By recursive, it means that the entities that relationship type relates to are from the same entity type. Okay, so this is kind of more like first draft of the ER design. So then we go back to the discuss the relationship type. So relationship relates two or more distinct entities with a specific meaning. So usually, if we want to narrow down to describe a relationship between two distinct entities, then that relationship can be called a relationship instance. Okay, so then I think we discussed the 2 tips or 2 ways to identify the relationship during the ER design. One is in for the relationship in the data description. The other one is use the attributes. So looking for the attribute and anti-types, both representing the same thing, real world entity. So the attributes and the related anti-type do not need to have the same name, but the two actually representing the same real world things or entities, then that is. So let me see. Okay, displaying a relationship type. So we know that given a database, we have so many different records, and we have a lot of relationship among those records. So some relationship actually represent the same semantics, like employee works for department. Okay, so then that's why we have a relationship type concept. So in the ER diagram, the relationship type is represented as a diamond box, okay, between the at least two anti-types. So that diamond box will be connecting to the 2 anti-types, okay. And then relationship types simply specify a relationship that have the same semantics and relates to the same anti-types, okay. In this case, works-on relates to 2 anti-types, employee and project, okay. So later we're going to discuss that for this relationship type, we also need to model its constraints or describe its constraint in the ER diagram. So we're going to discuss that later. So it just shows the first draft of the ER design. So in our first attempt, we need to identify the anti-types. We also need to identify the relationship types among those anti-types. Okay, so this is what we did in this design. So we identify 4 anti-types: employee, dependent, project, department. We also identify how many, I think 6 relationship types. So 6 diamond box. So all 5 are called normal relationship type. And then we only have 1 supervised as recursive, okay? It's called a recursive relationship type because it's connecting to the same anti-type twice. Then for the recursive relationship type, we also need to provide a role name for each way of the participation. Okay, so for example, we put supervised E on the left leg of this supervised relationship type, means that an employee, if participate the supervised from this leg, those employees are the supervisees, okay? With assign a role on the right leg called supervisor. So that means that an employee, if they participate this supervised relationship from the right leg, that means that that employee is a supervisor, okay? So then the semantics are clear, okay? So we relate supervisee with the corresponding supervisor. Both supervisees and supervisors are employees. Questions? Okay, so what else? I think that's pretty much we're going to discuss. So then I think I want to add one more. So relationship types versus relationship set. So relationship type only used to model in the ER diagram. So basically it's a schema description of a relationship. So it's identify the relationship name and participating anti-types. So that's the kind of straight line connecting an relationship type with an anti-type, okay? So in the ER design, only relationship type is showing in the ER diagrams. Okay, what is relationship set? So the current set of relationship instance in the database. Okay, so relationship instance basically describe a concrete relationship between the individual entities. So one relationship instance connecting two entities, okay, one from each participating entity type. So that's called relationship instance. So for the relationship type, we need to understand it. So because we need to record it in the ER diagram, but the relationship in the set or the entity set, they are not included in the ER design. So they are not showing in the ER design. So I think we kind of discuss the pretty much content. So I want to stop here. I think today you want to review that how to identify the relationship type. I think identify entity types, that is pretty easy and straightforward, but identify the relationship types usually needs kind of your thinking and also needs experience. So I want you to review what are the two ways that we can identify the relationship types. And in the next class, we're going to focus on the relationship type and also introduce the constraints on the relationship type. Okay, so that's pretty much for today. Any questions?